So before we get started, we're actually going to be using Axiom for the most part. So you need to have Axiom actually. So if you go to mattpachella.com/axiom-download, that's where you can get it. So there used to be a free version. There is still a free version, but for the most part, it's moved to a paid version, Axiom 2.1. So you can buy it here. It's relatively cheap for indie. $99, and honestly, it's very fast. So what Axiom is, it's a hard-coded solver, which is at the moment in Houdini, but it might make its way into other programs at some point. I don't know. This is what we're going to be using. There's also a non-commercial free version, so it's only available in apprentice and educational. So you can also try that one out. But that's what we're going to be using, and we are so make sure that you have this installed. It comes with installation instructions and stuff like that. So yeah, but now let's just actually dive into Houdini. All right, so we're in an empty scene. So let's just make a geometry node. Dive in there, and let's talk about Axiom. So this is Axiom Solver. You can just drop it down, and it's thinking for some reason. All right, there we go. So it has two inputs. So you can use VDBs, regular to how you would source just in the regular Pyro solver, or you can use Axiom source shapes. So let's just first show the source shapes and then just with the VDBs. So Axiom source shapes are actually, if you use those, it's a lot faster to solve. Inside of Axiom, but they're a little bit limited. So you only have what you have here basically. So you can use a sphere, cylinder, box, pyramid, or cone to emit from. Then you have what do you want to emit: density, temperature, fuel, and pressure for expansions and stuff. And you can use some noise, deformation noise, velocity noise, and the force, directional force. So that's basically what you have. And then if you plug it in, and if you play, you can see Axiom is extremely fast. So you can see we are just emitting some smoke, and it's pretty much real time. And we can do, after this, we can do a Pyrobate Volume, and let's just enable fire here. All right. Let's reduce, I guess, the fire here a little bit. Let's wait for this, and let's compute range. All right. So now we have some fire here. Of course, this is not really correct yet, but let's just go into the Axiom solver and just have a look. And by the way, before we do that, maybe make some interesting stuff here. So we can add some noise actually. Let's just have a look at the smoke as of now. So you can see we can add some animated noise. So we get some nice noise going on there. You can increase or decrease the feature size, strength. Or you can do something like this. Right. And again, here you can see like how much density should it emit. And you can see it's pretty much real time. So how much temperature. So if we do a lot of temperature, you can see it's going to rise really fast. And if I do very little temperature, you can see it's barely gonna be rising at all. Let's just do 1. And like you have some other stuff like deformation noise, where it's actually going to deform the original thing. Velocity noise, where it's gonna push out from some velocity. So just some basic stuff, and of course here the directional force, and you just turn it off. Just gonna do the temperature. So pretty basic, but they are really fast. So if I'm going to compare these two, let's do a regular sphere. And we'll get into all of the settings in here in a bit, but you can also do a regular sphere. Let's just have a look at the size. So we need, right, so I guess this is, right, if I make it 2, it's roughly around the same size. Let's do Pyro source. Let's make it, I guess, source. Let's just do it manually. Let's do volume scatter. Add a couple more points. Let's do density and let's source some temperature. And then you want to do volume rasterize attributes. And we want to rasterize both of those, temperature and density. Let's link it up to voxel size there, right? And let's do some noise here as well. So let's do an attribute noise. We can do attribute noise here. Let's have it go over density and over temperature. And floats, and let's say multiply. And all right. So let's plug that in instead. And you can see we also get some emissions going on here, and then with this noise here, you can do. And just play with these noise values. So maybe something like this makes a little bit more sense. Or I can just put it to 0 centered, I guess. So you can source both VDBs here, or you can use the source shapes. The Axiom sources are a little bit faster, but again, you're quite limited in what you can do with them. Or you can just use it this way. And so if you do it like this, this is similar how you would do it into the Pyro Solver, although the Pyro Solver also needs a burn field. So we'll get into that in a little bit. So let's have a look at the Axiom Solver itself and like the stuff it can do. So maybe so we can already get some detail. Let's decrease the division size a little bit. You can see it's still going to be really fast. Maybe let's do it a little bit less high. I'm running this on an 3090, by the way, but it's also fast on lower end cards, or not if you have super low end card. The main limiting factor is going to be your VRAM. So I have a 3090 which has 24 gigabytes of VRAM. So I was able to sim everything inside of the VRAM, but you also have an option to, for example, set it to CPU mode if you want. So I can put this to CPU mode as well, and it generally takes a little bit to switch. So let's wait for this to stop thinking. All right, so we're on CPU mode, and you can see this is a lot slower. I'm actually on a Threadripper 3970X, so it's not even a slow CPU. But the reason why you would switch it back is let's say you have a for example a 3070, 3080, only 8 gigabytes of VRAM, and that might fill up quite a bit faster. So in that case, you might switch to CPU mode. So you might do your look dev on GPU and then switch to CPU. But I've done all of the sims on my GPU, so it was actually quite doable. But yeah, let's discuss some of the other stuff. So solver here, main stuff where you do the division. You have different things here, which I'm not completely like. There are different way of solving. I could tell you what I think this is, but it's not going to be correct. So let's just leave it at the thing. I think reflection is more accurate. So I guess if you have more fast moving stuff, a lot of stuff happening, reflection might make more sense. And don't know what traditional is. So I guess leave it at this, and you might change it. But again, probably maybe look at the documentation if you want to know more than what I'm saying here. So that's the basic stuff. Over here you have the sourcing, so you can source a whole bunch of different things. Let me just switch it back to the Axiom shape for now because it's a little bit faster to sim. But you have you have a bunch of stuff. You can source density, temperature, fuel, velocity, pressure, and more stuff like that. So pressure right now is not really doing anything, but let's say if I were to source some pressure here, you can see we're actually getting some sort of expansion going on there. So if you're going to do like explosions and stuff like that, then something like pressure might be good. If you're going to be sourcing that with a PDB instead, you need to make sure that the names are correct. So a lot of stuff like density, here it's called source density, but it will automatically rename it. It won't do that for everything, but you just need to match the name here. So let's say you want to source collision velocity, or let's say for fast moving stuff, you need collision velocity, stuff like that. You need to actually name it like that, and the capitalization is also important. So let's just try that out with the pressure, for example. So I could go over here and then say, have a look at the, so it should be called source pressure. We're gonna be going here, call it source pressure. We're gonna rasterize source pressure, and we're gonna go in here. Let's play. You can dial it up there. You can see this works. So you just need to make sure that you match the naming convention here. That's again also if you're doing collision. Which again, like for example, I had a shot where I had a door moving open with fire coming off, and you had to really source the collision velocity, else the collisions were not going to work. So, and I was I was breaking my head on why that wasn't working, but you need to really match the name there. So that all works. Oh, I'm tumbling my camera, which I don't want. All right, so essentially that's how you can sort of source this stuff. Let's just turn it off for now, but yeah, that's how you source different things, and you can just go through here and see whatever it is you want to do. All right, let's move along a tab to simulation tab. So let's just go in here, and right, so here's all the interesting stuff here. For example, you have dissipation. So if I increase the dissipation here, you can see it's gonna dissipate a lot faster. It's gonna give us a more sort of a flame-like look. Can increase the cooling rate, so it's gonna cool a little bit quicker. We want to reduce the buoyancy. Let's increase the like that, and maybe source a little bit more temperature. And on the Pyrobate here, let's compute the range. Maybe you want to do a little bit of a darker things. You can see we have some temperature in here, and then it, but you can see it's still very bulgy, not looking great. So of course, a lot of other stuff you can do in the simulation tab here. You can see by default here it has turbulence turned on. If we turn that off, you can see it's just going to be very simple wispy smoke. So if you want to do wispy smoke, I guess that's how you do wispy smoke. Let's just walk through all of these steps one by one. So gravity, I guess, makes sense. What it's going to do is going to introduce gravity in the mix. And if your buoyancy is going to be enough, then you're going to have stuff still moving up. But let's say you have an explosion and stuff falling down. You want sort of, or like dust or smoke falling down. You might introduce some gravity. I had it generally turned off, but depends on what you're going to be doing. So you have wind. Wind is going to essentially have it blow into a certain direction, but then also have an option, for example, to add some turbulence into the wind. So you can make like a nice turbulent wind here. So that's separate from the turbulence there. Aside from that, you also have regular force, and force is just going to be a directional force. So you can blow it into a certain direction. So you can blow it really sideways if I wanted to. All right. Pretty cool. Viscosity, let's talk about it a little bit. Let's first have a look at the at turbulence. So we already had turbulence on. Again, this is just going to do a turbulence field. And if we're going to be in here, turbulence field, you can set the swirl size and strength. It's just a noise, essentially. So if I really increase the swirl size, you're going to get, you can see, really big swirl. So essentially, that's the size in which the swirl is happening. So 2 is going to be, I guess, a 2x2 sort of meter grid in which the swirls are happening. If I make it really small, you can see I get a lot smaller sort of turbulent stuff going on. It's really... make it, all right, it's too small for the amount that I have. So you can see now we get some nice small detail. you have two of those. So you can stack turbulence. You can do one small one, one bigger one. A little bit of detail there. And of course, if we want to do detailing, of course, disturbance. And disturbance is going to be disturbing the field, sort of pushing it out in different ways. And if you turn that on, let's turn off turbulence for now, so you can easily see what's going to do. You see, that's really breaking it up. So we get, if you don't want a wispy smoke, but you want more of a sort of a, well, like this, more detailed smoke, you would do disturbance. Disturbance by itself is linked to the division size times 2. You can of course override that if you want. You can unlink it, stuff like that. But by default, this is quite okay. You can stack them here. So this one is multiplied by 4. So you have one there. So you have the more smaller, like the intenser, like the bigger one with bigger blocks, and then the other one with smaller blocks. So, and if we want to really try this out, let's just unlink this. Let's say we do block size of 1, so really big. You can kind of see what's going on. So it's 1 is a 1 by 1 by 1 meter block. So if we make a box, that's essentially the size in which it's disturbing. Like if I were to make it 5, it's going to be, you can see. So you have a bunch of options there. I'm gonna undo that. All right. Control field, you can control it by certain things. For example, I want to do it by the velocity. So for example, if I want, when the velocity is low, maybe I want to do a lot. Or the other way around. This looks better. You can do it by temperature. So if the temperature is low, it's gonna disturb more. And if you do it the other way around, you see high temperature now, it's gonna be disturbing here more, and then it's gonna disturb less over there. So a whole bunch of things. Let's just do this. Set to the default. So no control field. So yeah, a whole bunch of stuff that you can play around with. So you also have confinement. Essentially, if you hover over it, add small details to the velocity field. So it's gonna give like nicer swirls and stuff like that. So if we just enable it with some, it's gonna be hard to see, I guess, the difference, but. To be honest, I always just play around with these settings, and then if it happens looking good, then all right, that's too much. All right, so you can just increase the values. Like you can see here, it's really adding sort of these small details here, which is here too much, but make it a little bit more grainy. Well, I guess we can do a little bit of confinement. And this might, well, that might be actually be good to show viscosity. So if you enable, for example, viscosity, it's gonna be a more thicker, so more thicker smoke, maybe like underwater type thing. But let's turn it off for now. So generally, what you would do, you would just scale different sort of like you would layer these types of things. So multiple turbulences. Multiple, yeah, just a whole bunch of things. So you can add a little bit of wind. You can see it's still really fast. And the output volume here this is still relatively low, but if we can actually increase the detail quite a lot. You can see now we actually, it's still not super high resolution, but you can see we're actually already getting quite a lot of detail, and it's still really fast. And if we really increase this, and then we're really gonna get a lot of detail. And you see it slowing down, but if we're gonna have a look, this is starting to get to sort of good mid-resolution size sims, and it's still pretty much workable real time. Like if I were to do 0.01 now, that's gonna be a production level sim probably. This is probably even going to be beyond production level simulation. Probably what we had before with the 0.2 was already good enough for, I guess, something like this would be good for. So you can see this is really nicely detailed. And you can see here pretty good resolutions. So if we let this run for a little bit, and we're probably going to have a grid that's around production level. But generally what I aim to for is like production level sims are generally around 500 by 500 by 500 to 700 by 700 by 700 ish. But you can see it's still it's really fast. So that's with that's essentially the stuff here. So you have more things that you can do. You can start adding substeps. If you have a lot of fast moving stuff, that might be something you do. Maximum amount of voxels. Of course, start frame, stuff like that. Yeah, combustion is going to be more if you're going to ignite things. So now we're actually we're more sourcing the density and temperature directly there. But you could also, for example, say, all right, don't want to source density, want to source fuel instead, and enable combustion. And then essentially what it's doing is sourcing fuel, and then the fuel is going to be ignited by the based on the temperature. So if I make this too high, it's probably all right. It's still igniting. If I make it really high, you can see it doesn't ignite. All right, there we go. So now you're really so you're emitting fuel, and then the fuel gets burned up, and then you get nice fire. So now the smoke actually gets created from the fire. So because we're not sourcing any density directly, or are we? Yeah, we're not. As you can see, turn it off there. Also turn it off here if I want. And again, you can also create all these fields over here yourself. So it's yeah, a bunch of stuff you can do. So that's the combustion setup. You have control here over the fuel burn, fuel inefficiency. You see, fuel inefficiency is gonna keep a bunch of the fuel that's not igniting, and then later it's moving along, and then we're getting a real gas explosion here. So. So with the fuel burn, you get that explosive stuff. You can see pretty nice. So let's also talk a little bit about doing some collisions on this. So it's quite simple actually for Axiom. Let's say I do a pig, and all you need to do is make an SDF from it. So let's just make I guess move it up and to the side a little bit, really good, a little bit bigger. So just make a VDB from polygons from it. It doesn't necessarily matter what it's called, because if I were to do a collision source here, so that would make it a different, it would make the VDB a different name. So here it would be called collision, here it would be called surface, but both will work. I can just show you a little bit. So here we have stuff being, oh, I think I need to actually move my pig to correct location. All right, so we have the fire. Let's move it a little bit more towards this thing. All right, so you can just plug it in, and you can merge it in with other VDBs and stuff like that. So you can see, right? You can see now it's gonna be burning right around the pig. So you can see it's working nicely. So this also works in conjunction with, like, let's say I disconnect my Axiom source there, and I can just merge it in with a regular VDB for emission, and that's right. Let's see if this actually works. So yeah, I had to open up a older file because I forgot to record the collision or the collision part. So that's why this might look a little bit different. Let me see why this is not working. So we have density, temperature. So this should theoretically cook. Oh yeah, that's because of course we were emitting fuel instead. All right. So I've got some stuff going on here. So So here we have this, and I can actually just plug in the pig as well. And you can see works perfectly fine. And if I were to do it with a different name, so for example with the collision source, and then play, see, it still works completely fine. So yeah, no problems there. It all just works. Just make sure you plug in an SDF, and it's gonna work. And if it's gonna be so if I put in this, so as long as an SDF is gonna be collision. If I were to make this a fork instead, you can see it's just going to emit as smoke. So make it an SDF, and it's going to do the collision thing. Hooray. So yeah, that's pretty much basics here of Axiom Solver. Of course, there's a lot more stuff you can do, but I think for a basic introduction thing now, this is pretty good. Again, if you want to source more things, you can do that over here. So you can see how fast it is to make nice looking sims with just Axiom Solver. It's great. I really like it. It's gonna, like, if you're gonna do very custom stuff, Houdini Pyro Solver is probably still better, because the thing is with these Axiom Solver here, we can actually dive in. You can see here's the Axiom Solver. It's actually a hard-coded node, so you cannot dive into it. So you cannot put Houdini gas nodes in here. So this is not DOPS. It's actually a standalone solver. So technically you could also make one for a Blender or for Maya or for whatever. It's a standalone solver. This is just happens to be wrapped inside of Houdini because that's the first program it is in. But I think it's likely that he will probably make builds for other software. So yeah, if you want to support any of that, I guess buy the plugin. Matt's doing a great job. Just one guy making this solver. It's pretty incredible. So yeah, and again, all of that stuff also works with if you source it directly here with VDBs. Right. So also let's talk a little bit about the Sparse Pyro solver. So they have changed it a little bit in a recent version. I don't remember exactly which version it was. I think it was 18.5, so previous one. So first of all, there's for this demo, I'm going to use the SOP Pyro solver, but just in case you didn't know, actually the SOP Pyro solver, if you can just dive in, you can see it's actually a .NET under the hood, where you can just plug stuff in here, gas nodes, whatever. So it's just easily wrapped up. So this is, the workflow for this has changed a little bit. I haven't used it extensively yet for really, for a lot of Pyro sims. I have done some smoke sims with it. So I'm gonna just basically explain the rough workflow here. Not gonna go super into depth and discuss some of the changes. Some of the changes to me are still not super logical. I'll go into that a little bit. But let's first just copy and paste, I guess, the nodes here. So we have some extra stuff here to work with, and you can just plug it into volumes there. And then if you play, you can see it will actually start simulating. So this has a couple of presets. You can do some quick setups. So you can say initialize fire, for example, and then it's going to be set up to do some fire. Maybe let's copy and paste a bake volume on it. And then if we play, right, see, it's going up quite a lot. And we also actually missing a couple of fields. So if we go here in the thing here. So if you watch some older Pyro tutorials, including some of my own, this stuff here, like the user interface will be very different. And also you see there's a thing here called burn and flame. So we don't have those yet. So we need to probably make a burn field. So let's just call this burn, I guess. So we have burn field. And let's just also do the noise on our burn field. So burn gets sourced into the flame field. Well, so okay, now I'll get into like the new thing. So here's essentially what the Houdini help says from it. So here's the flame field. So burn gets sourced into flame. And what I just showed you here with Axiom is you have this fuel thing, right? You can source fuel and then it ignites, which to me makes sense. That's also what Pyro used to do. But now there's a different thing, or differences with legacy Pyro. Prior to Houdini 18, Pyro simulations involving combustion used the fuel field. In hot areas, the fuel would ignite, contributing to the instantaneous burn field. This burn field would turn to refresh heat, which captured the emissive parts of the smoke. So it's actually just how you imagine fire to work. You have fuel, and then you ignite it and then it starts burning and stuff. New recommended workflow requires instantaneous burn to be generated. So you generate the burn yourself, so you don't go through fuel, you just start sourcing burn. And then that will in turn generate temperatures and divergence and stuff like that. So divergence is the expansion of the fluid sim. Right. So there's benefits. This approach has advantages of predictable, more control, for instance. But I guess that's the case because you can directly source it. But it's just that from a just physical standpoint, just sourcing fuel and fuel igniting makes more sense. I guess if you source just burn fuel directly, you can just also inject it. You don't have to wait for it to ignite, stuff like that. But not completely, doesn't completely make sense to me yet. But regardless, we're just gonna do a little bit of fire for now, so we don't necessarily even need a lot of that because we're just gonna do some fire. But I thought I'd throw that in there. So talk about the Pyro Solver. So here on the sourcing tab, you source stuff, so density, temperature. This is set to pool. There's multiple ways to source volumes. So if we just go in here, I guess search for pool. Pool. Should be there. All right, pool. Values in the target field are pushed towards the corresponding entries in source volume in accordance to acceleration strength. So you have some controls over how fast it accelerates, stuff like that. I generally think adding it is just easier to think about, but the default is pull. So I guess we can leave it at that, but you can also put it to add. It will also work. So here you can just source all of the different things. Then you have fields and shape. So fields is controlling the different fields. So density field, temperature field. So for example, here's where you do the dissipation. So let's say if I play and I do very high dissipation, and you can see, by the way, it sort of moves out. It's because the whole thing is just moving up quite a lot. And if it's dissipating here, it's like the density is now disappearing, but the temperature is still going out of this, and the whole sparse field here, the thing is resizing based on the density. So the density has already disappeared and the fire is still going. So yeah, that's the thing. Flame, I don't think in this case is going to do much because we're not really dealing with a combustion setup. But this is where you do stuff like that. So and there's some more stuff here, I think. So if we want this to rise a little bit less, there's a couple of things we could do. We could increase the cooling rate, so it's gonna cool a little bit faster, and we probably need to go in shape and decrease the buoyancy. And we, of course, need to turn down dissipation a little bit. All right, so you can see now it's rising a little bit less, and maybe do even less buoyancy. And want to cool it a little bit faster. All right, maybe you want to increase the fire here a little bit. All right, so we got some boring sort of flame smoke. Like we don't really have any forces now, so it's not going to look great. But here you control everything regarding all of the fields that you have. And in shape, that's where you shape the whole thing. So we already did the buoyancy thing, but here you can do this stuff like, for example, the turbulence, similar to how we had it in Axiom. So if we increase it, you can see we add turbulence. We can make it bigger, and you can do the same things like swirl size and stuff like that. So turbulence is always nice if you want to do like symmetrical sort of wispy smoke. Just add regular turbulence in it. So you can see it's still very puffy. And you might also notice that in here, like there's only one turbulence, but that's where you come, that's where this comes in. So you can also, let's turn it off here. You can also actually also do gas microsolvers here. So you can also do gas turbulence and just put it in force here. And then if we play, see we have our own little control here. So you can stack them like that, and then you can merge stuff in. So if you want to do more, and Generally, if you're gonna do more advanced effects, you will probably turn the stuff here off and then just do everything in here. Because then you can just build your own sort of microsolver network. So that depends on what you want to do. But let's just keep it in this for now, because we're just going to go over some basics before we go into the rest of the file. Disturbance is, yeah, it's the same like we had before, of course. Let's turn off turbulence for now. All right, so if disturbance, we probably need to crank this up quite a bit to really see something. All right. Yeah, right, so you can see it's starting to disturb. Maybe 15. You can see it's still relatively fast with this solver. This is because we're at a really low resolution. You might notice that we're at the regular power. So if we start cranking this up to get some more detail in, it's still relatively fast, but we're still not super high resolution, and it's a lot slower than Axiom was. It's because at the moment this is simming on my CPU, which is a Threadripper 3970X. There's actually multiple ways you can solve this. So Sparse uses sparse volumes. So if you're familiar with what a sparse volume is, it's essentially, it doesn't, like normally if you have a non-sparse volume, essentially what it will do is it will, if I add a box to this, so it would simulate this sort of entire sort of box. And then if I had another pyro, like if I had another source, for example, over here, I'm just moving it, just you prove a point, and if I were to merge it in, merge. So if I had another source, it would simulate this entire sort of box, because it needs to simulate there, simulate there. If you have sparse, then it does only needs to simulate the actual area. So it has a little bit of bounding region around it, and that's where it's gonna simulate. You can also put it to dense. So it's gonna do the actual full thing. And might be pros and cons to either, but sparse is generally faster. And you also have minimal OpenCL solve, which it's not gonna support every gas node. So it kind of depends on what you're gonna do. So this is gonna run on your GPU. You can already see that some stuff here is now breaking. So some nodes are not supported by that. If you wanna see a setup for that, you can just type GPU, and you can see GPU torch. You can just drop it down, for example, and then it's gonna think for a little bit, and then see it drops down the whole network. And then we have here, the play, do your thing. Oh no, it's gonna think. Don't hurt yourself, Houdini. All right, so now we can play, and you can see here's actually some fire, and you see this actually really fast. You see it's not filling up the bar. It's just doing a sparse solve, sparse CL solve, and it's only solving this area. And you can see it's really fast, but it's limiting in some regards. So this is the sparse, like the minimal OpenCL solve, I guess is more similar to what Axiom is doing. But Axiom is at the moment a little bit more fully featured. I'm sure the minimal solve is gonna improve down the line. But you can just dump down things like that. And that's also with other things. You have Pyro, Bonfire, Fireballs. You can have a look at these demo setups to see how they're all working. Let's just put this back to sparse. Oh, wait. What am I doing? Why is it stopping the sourcing? What did I change? What did I change? Okay, I just undid a couple of steps. I wasn't sure what I changed. But here we are. We're back with the thing. Let's see if we now put it to minimal. Kind of felt that just putting it to minimal broke the thing, but I'm not sure why. But I guess now it's gonna work. All right, that's weird. And then put it to sparse. Set. Okay, interesting. Putting it to minimal and then putting it back apparently breaks a couple of things. So I guess that's a bug, and I might report that. Anyway, here we are back with a little thing. To the shape tab. So it's very similar to some stuff in here. The wind is just similar to what force here was. So because it doesn't have the turbulence, but again, you can just make the turbulence yourself in here. Some other stuff, shredding. So really increase it so we can actually see what it's gonna gonna do. I think shredding is not really gonna make a big difference if we don't have any disturbance. So let's really increase the disturbance as well. All right. So I undid a couple of steps and now it works again. I actually noticed a bug where if you, so you can see now it's working fine. Like I can play, and if I put it to minimal OpenCL, it's gonna do the thing again. And then when I put it back to sparse, you see it's still doing that thing, which I think is probably a bug. But so I guess that's what was causing the issue. So anyway, let's continue talking about some more of these stuff that we're doing here. So we also have shredding here, which at the moment is not really gonna do much, even if we increase it. Because it's set to use the flame field. We're not really doing much with that. Let's put it to density. Threshold field. All right, so now you can, I guess, see a little bit easier going on. Let's go into fields. Let's decrease the dissipation maybe a little bit so it stays a little bit longer. You see, it sort of breaks up the thing. I guess it's the help file is probably going to do a better explanation of whatever it is that I'm doing here. Shredding. All right, here we go. Yeah. Just apply random forces to break up simulation, just similar to disturbance, I guess. Shredding, effectively adding chaotic motion without speeding up or slowing down. Okay, I guess it's similar to disturbance in that case. I don't. What I always feel like it's doing is that it's sort of just pushing stuff out, making sort of little peaks in explosions that could look quite nice, but I don't use it that much. But again, my explanation here is probably not the best. Flame expansion, I guess it's gonna be based on the pressure. So I guess this would make sense if we were to source more. Where is it? Source more burn. Am I doing the burn? Oh wait, we weren't even sourcing the burn field. I guess that's why the shredding also wasn't working on the. All right. So, all right, yeah, you can see it does work. So we forgot to rasterize it, so that's why that wasn't working. But now you can see kind of same what we had with Axiom. Oh my god. Then we need to also turn it off on the expansion. All right. So you can see it's similar to what Axiom was doing when we were sort of igniting the fuel. So you can see, boof. And if you do some turbulence there, you're gonna get a disturbance. We need to increase that. All right, then you can see you can get some nice sort of some nice shapes in there. I guess shredding here now would also, they could do a little bit less. Oh yeah, okay. Now you can see what I mean with it's sort of creating these out of these chaotic outgoing things. But yeah, with a little bit of pressure, I guess like this is how you can do sort of a nice sort of smoky type thing. Let's change the cooling rate a little bit, because now I guess I want my fire to stay on a little bit longer. That's on this thing here. Let's just increase this and maybe we can do the scattering visualization. So you can get some explosions going on. Yeah, and then here the look thing, we're not necessarily using that here. It's kind of doing the same as the Pyrobate Volume there. You can see this is just doing the look. Does it have a... don't think this is a scatter option. So the Pyrobate Volume essentially does that and more, because it also has the scatter volume thing and all of those other things. So I just use that instead. scatter is a little bit slow, because what scatter is doing is sort of just scatter essentially. It's a fake way of doing sort of bouncing inside of your volume, which comes in play when you're rendering in Karma. We're gonna get into that when we get to the rest of the actual shot, because Karma can render volumes really fast, but the bounce light inside of it, so multi-scatter inside of the volume, is really slow. So if you enable that, if you enable multiple bounces, like your thing will grind to a halt, basically. Oh, and the viewport is breaking again. Let's do... All right. But it will really grind it to a halt. While with the bake volume, essentially what it's doing, it's sort of scattering points inside of the this volume. Well, it's not scattering points, but just to sort of make a representation. And then it's sort of fading, like putting a little bit of the temperature inside of the smoke. So it will look like the light is sort of scattering through the smoke, which is essentially also what you're going to get if you're really bouncing light through a volume. But it's a lot faster. It's fake. So for explosions and stuff like that, it's gonna look completely fine. If you're gonna render a cloud, you probably actually want actual bounces, so you get like a nice look. Because with clouds, for example, cloud rendering is really slow if you're gonna do a really realistic cloud rendering. Because you need a lot of like bounces in between the thing. That's why the Disney cloud example is quite interesting if you haven't heard about it. So if you haven't heard about it, there's the Disney cloud. You can download this, but you can see what clouds don't really have. They have this sort of inverted look where it's like darker on the edge, but you get that with a lot of sort of light bouncing, because remember, cloud is just essentially a really thick sort of watery fog, and light will bounce through it. But to render this is quite slow, and there's a ton of examples of people rendering this in different render engines, and you really see a big difference depending on where you render it in. Anyway, getting off topic here a little bit, but yeah, that's essentially just the basic things here. Of course, you can source other things here. You have here things inbound with what does the resizing happen, which fuels I'll use, how much padding. So the padding is the stuff around it. So if I were to increase the padding here, I get larger padding across my area. We'll make it a little bit slower. A bunch of other stuff you can do, close boundaries, whatever, voxel size, substeps, all of that stuff. But I guess that's good enough for sort of a basics. Then you kind of know now how to sort of do sort of basic flames in both in Axiom. So we have here some fire, and with Pyro. But as you can see, Axiom is a lot faster, because this is still very low res. And if I play through Axiom, this is... Let me reset it for now. See, this is pretty much real time, even though it's just slightly higher resolution than this. But with Axiom, I could really crank this up. See, it's still really fast, but now we're really starting to get a lot more details in here. You can see still really fast. So you can see how Axiom is really gonna make a difference with a project like this. So yeah, that's just the basics for, I guess, for doing sort of just some simple stuff with both Pyro and Axiom. For the rest of the sort of tutorial series, we're going to be using Axiom. Because that's what I use for the project, but I just wanted to include sort of this sort of basic introductory thing for both, so you kind of know what's going on here. Because then I don't really have to dive into every single parameter on the when we talk about the actual shot, because of course then it would take many hours. Because for this shot itself, I'm just going to walk you through roughly what is going on. So yeah, let's just get back into the actual regular file to see what's going on there.